Welcome back. This is an Aleks training video on determining the volume of base needed to titrate a given mass of acid. A titration is what you would run if you are trying to find the concentration of an acid or a base that you don't know. You don't know what it is. You know that it's a certain acid or a certain base, but you don't know its concentration. And there's no way really to put it in a machine and find out what its concentration is. So the best way to do it is to titrate it, which just means mix it with, if it's an acid, mix it with a base. If it's a base, mix it with an acid. And then when it's neutralized, the pH, which is easy to measure, goes to 7. It goes from acidic, which is really low pH, to 7, which is neutral, or it goes from very basic, which is up to 14, down to 7, which is neutral. So it neutralizes it. If you know exactly the amount that you used, and you know the concentration of one, and you know the amount you used, you can figure out the concentration of the other. It's a perfect way of figuring out a concentration of something you don't know, is titrate it. So what's happening here? You've got citric acid. And citric acid is a triprotic acid. It means there's 3 hydrogens to donate. So 3 hydrogens are going to be donated. You're going to put it in a flask, and you're going to then titrate it with a certain concentration, you know its molarity, of sodium hydroxide. Okay. So what are you going to have? You're going to have, starting with your citric acid starts H3 because there's 3 protons to give, and then citrate. Citrate is C6H5O7. Okay, it's a solid. And then you're going to, now it's in solution, but it's a solid that will dissociate. It's a weak acid, so it's not going to dissociate perfectly, but lots of it will. And then it will be in a solution, which means this salt is broken apart into sodium hydroxide. It's aqueous. And whenever you have a titration reaction, you are always going to make the same things. You're going to make a salt plus some water. Where does the water come from? Well, the hydrogens are going to be donated to or transfer to these hydroxides. Okay, so the hydroxides are going to act as a base. It receives these hydrogens. This is acting as an acid because it's donating these hydrogens, and the hydrogens are going to transfer. When 3 hydrogens connect with 3 hydroxides, you're going to get 3 units of water. Okay, so you're going to end up with water, H2O. So OH, HOH is the same as H2O, so you're going to get water. Plus, you're going to get some kind of a salt. And the salt is going to be, the first part of the salt is from the base. Okay, so you're going to have sodium something. The second part of the base is going to be the back part of the acid. Okay, so the cation of the base will be the cation of your salt. The anion of your acid will be the anion of your salt. Okay, C6, write it in black. C6H5O7. Okay, now let's get all this together. This is united with 3 positive ones. That means this must be a -3 because it takes 3 positive ones to balance with it. So if it's -3, how many positive 1 sodiums will balance with it? Has to be 3. Okay, so I'm balancing now. So if I have 3 sodiums on this side, I'm going to have 3 sodiums on this side, which means I have 3 hydroxides. And so I have 3 hydroxides and 3 hydrogens, so there's 3 waters. Okay, so this is a balanced equation. First part is balanced. Now, we're really not interested so much in the sodium Okay, the sodium is going to be dissolved in water, so it's not going to be connected to this. It's floating in the water. It was floating in the water at the beginning. So the sodium really is a spectator ion. You can kind of ignore it, which means you're going to have an acid, and these hydrogens are going to transfer to the hydroxide, making water. And then you're going to have the base that's left over is going to be the acetate. Okay, either way it works. All right, so they're asking you to find out how much sodium hydroxide do I need in order to reach a final equivalence point. So an equivalence point is when all of my acid is neutralized by all of my base. My base and my acid cancel each other out. Okay? So what does that mean? It means that my acid, I have a 1 to 3 relationship. 1 to 3. Okay, so I have 1 mole of acid to 3 moles of base. All right? So how many moles do I have that they've given me? They've given me 0.232 grams of citric acid. Okay, so if I have 0.232 grams, how many moles is that? Because remember, I have to go to moles before I can go into the balanced relationship of 1 to 3. Okay, 1 to 3 is only numbers, and mole is a number. Gram is a weight. It's not a number. It's not numbers of molecules. It's how heavy they are. So I need 1 to 3 based in moles. So I have to go from grams to moles. So I need to know how many grams per moles is this substance here, citrate. So I've got 8 of them, 3 and 5, times 1.00794. That equals 8.06352. I've got carbon. Carbon is, there's 6 of them, times, and atomic mass of carbon, 12.0107. That's 72.0642. And then I've got oxygen. There's 7 of the oxygens times 15.994 equals 111.9958. So its atomic mass is going to be 192.12352 grams per mole. All right, so I've got 0.232 grams. 0.232 grams, okay, and there's 192.12352 grams per mole. So I'm going to divide that out. I lost my calculator, of course. I'll use my cell calculator. Okay. So I've got 0.232 divided by 192.12352. Okay. Gives me 0.00120.756 moles. Okay. Now I've got numbers. The mole of acid is to 3 moles of base as 0.00120.756 moles of acid is to X moles of base. All right. So this is going to be times 3. And I've got base is going to be 0.00362267 moles. Okay. All right, now I have been given 18 molar sodium hydroxide. Molarity equals moles of solute over liters of solution. I know that the hydroxide is what this is, the base. I know that its molarity is 0.1800. Okay, I'm trying to find liters. That's how much. I'm done when I find liters. They're asking me how much liters it is, and then I have moles over liters. So my moles is just what I found out. It is 0.00362267. Okay, so how do I find liters? I'm going to move the furniture. The liters goes up, molarity comes down. So I'm going to take this number and divide it by 0.18, and I've got an answer of 0.0201254 liters. So first of all, let's look at my significant digits. I've got 3 here, I've got 3 here, so I need 3 here. So it needs to be 0.0201 liters. And most of the time you wouldn't do this in liters, you do it in milliliters. So 1, 2, 3, it's 20.1 milliliters. Okay, very involved problem. I'm sure you have to look at this a couple times or more to understand, but I'll help you in class.